I will show you some elements of climate control, including housing, in the next 15 minutes. My presentation is firstly describe some animal needs from science, you could say, some indicators, how can you detect animal-based measure or heat stress based on animal-based measures. And the third part is solutions. We partly discussed some solutions yesterday afternoon, and we can continue later on in the roundtable discussion. Well, this is maybe the basis, and I shouldn't go in detail, but this is the temperature, indoor temperature for the animals, and this is the heat production. But the point is, and that's what we decided yesterday, in the pig husbandry we should focus on this area above the upper critical temperature. This is what we call heat stress, and in fact this is the limit. We should not pass this temperature, and it is different for the different animal categories. Here in another type, it's the body weight of the pigs. You see this is birth, then the upper critical temperature is almost the body temperature, the rectal temperature. This is the moment of weaning, and then it gradually decreases until 22 degrees at 120 kilo slaughter weight. So you could almost say that the majority of the finishing pigs around slaughter weight are suffering from heat stress. 22 degrees is not a strange temperature within a building. In a table, again the upper limit of the thermal neutral zone, and I think Mette showed it on the truck at more or less the same temperatures, but on the truck the animals don't have any food in their body, so on the truck it can be even a little bit, a few degrees higher. But this is just in a normal situation with normal feed intake. And then you see what the most important categories are. That's the finishing pigs above 60 kilos. So that's the category that's important. And the lactating sow with only 21 degrees upper critical temperature. The pregnant sows are 5 degrees higher, because they eat almost, I guess, 1/3 of what a lactating sow eats. So feed intake is very important here. And Lars mentioned the bedding system, so the bedding can also affect this, and I think straw bedding, deep bedding, will also lower the upper critical temperature with 2-3 degrees. So this is all based on a concrete floor. And I think fully slatted, in fully slatted buildings it differs 1 or 2 degrees with partly slatted floors. So if you have a solid floor for lying on, the upper critical temperature is 1 or 2 degrees higher. Well, this is also often used as a kind of indicator, the temperature humidity index, but we are not very fond of it, because in fact you need, for every category of pigs, for every body weight, you need a new table. So this one is based on a body weight of, I guess it's 15 kilos, and there is just a lack of information. We don't have a series of these graphs for different body weights. So I see them sometimes appear in publications, but my message is, be careful with it, because it's often based on a certain body weight, and then you should translate it to another body weight to make it valuable. Yesterday we decided not to focus on cold stress, because the majority of the climatic problems is in heat stress conditions. The only category sometimes suffering from cold stress are the newborn piglets, here huddling a little bit and also looking for contact with their mother, so the heat lamp and the mother. And of course this position is also very risky if the sow goes up and down. And if you look at the possibilities of the pig itself to regulate the thermal environment, there are a lot of options. So change the lying pattern, change the lying position, so more lateral or sternal. Lateral you lose more heat, and when you lay sternal on your belly, then you have less contact with the floor, and it's more insulating. The lying, I've called it place, but you can move from the solid floor of the bedded area to the slatted area, or even to the outdoor area where there is wind and a cooler outdoor temperature. The pig can increase the respiration rate and also tries to moisten himself with the skin with water, with like artificial sweating, I always call it. So we can also offer the pig a lot of possibility to look for a solution itself. And this is more or less the temperature bar with the different scenario or the different solutions the pig can choose itself. It's just a translation of what you saw earlier. And we have been looking at indicators, and what we did, that was all the research in Wageningen, where we had pigs in a partly slatted pen, and this was in respiration cells, so we gradually increased the temperature every day a degree extra, and we looked at the behavior. And this one is the place where the pigs lie. It's 70 kilo pigs, partly slatted floor. Until 18, 20 kilo, nothing happens. They just lie on a solid floor. That's what they prefer if they have the choice. But from 20 degrees on, you see the percentage of pigs lying on the slatted floor increase, and that indicates that some of the pigs start to, well, suffer. They are experiencing the heat and try to find a cooler place. And of course this cannot be much higher than the 40%, because in the end there is no place left on the slatted floor. It was not a very big pen. But this is what we call a broken stick analysis, and you see at what temperature pigs change their behavior. And this is the effect the same, but it's related to feed intake. You see until 25, 26 degrees pigs eat as they should do to produce body weight, and from then on it goes down. So it's reduced. So you could say the 25, 26 degrees is also a kind of a tipping point. And that's the same for respiration rate, to lose heat. So that also starts to increase from 23 degrees upward. So that's very much in the direction of the 22 degrees I showed earlier in the table. Well, and next to the temperature, we have the air quality. I will not spend so much time on it, but I think you realize that high dust levels, they have an effect on the pig farmer, him or herself, and also in the pigs. So it's always positive if you can lower dust levels in the pig house. I think also in an earlier meeting I spoke about a project where we, together with our competent authority, we looked at the exceedance of certain limit values. This is the percentage of pigs or farms where the level of CO2 and ammonia, more than 30% of the farms exceeded that value. So that's really a lot. We used also certain animal-based measurements with ear score, pig fouling, and even pen fouling. So you see pen fouling and pig fouling is also 30% on 30% of the farms. That's just an example of animal-based measures you could use as an indicator. Well, then I come to the solutions. Yesterday we had a discussion about pen design or house design, even the orientation of the building towards the sun and towards the wind direction. But the main focus is to reduce heat stress. And heat stress is not only important to improve welfare or to prevent heat stress, not just welfare, but also production point. So it will cost you money if there is too much heat stress. Insulation of the building, also space allocation, and not only in square meters but also in cubic meters, so there is some volume in the building that also serves as a kind of a buffer. And for instance, no windows on the south side of the building, painting your roofs white, that also keeps the building as a whole a little bit cooler. And then within the building, within the pens, the floor design should be large enough to distinguish some functional areas. So give pigs the choice so they can look for the solution themselves. And then of course it's also important, where do you measure? If you measure temperature, where do you measure it? In the room or in the pen? And I don't think we have a good protocol for that, because we also know that there is a distribution is not nicely or uniform in the room. And then of course you can do something with climate control, with the air inlet, outlet, cooling, heating, and variation of systems. And of course we know that all heating systems, ventilation systems and air scrubbers, they cost a lot of energy. So it's a lot of euros, and big farmers like to save euros. So at this moment or in the next few winters we will see a lot of problems with climate control, I'm afraid. Yeah, and this is just an example of high ammonia levels in the winter at low temperatures and low ammonia levels in the summer. So during heat stress we shouldn't pay much attention to ammonia concentrations indoors. Okay, some other solutions. We can use the cooling capacity of the soil. So these are pipes buried in the soil, and the air, the incoming air is going through those pipes and can lower the incoming air with 5 or 6 degrees. And in fact it's costing it's costing hardly no energy. Yeah, what you also see is try to keep the fresh air, the incoming air, low, and then this is a smoke test. So then it spreads gradually, or it mixes with the existing air in the pens. So this looks very nice. In the past we had some systems with fresh air coming in from the ceiling, but that gives a lot of effect you cannot very well predict. So the predictability is not good enough. But in my opinion, the water is the best way for evaporative cooling. So you can wetten the floor, especially when pigs start. You can use showers indoors with certain intervals. You can use indoor sprinklers or sprayer to cool the air. So this is to cool the animal, the skin. This is to cool the air. But one of the most promising methods is to use high pressure fogging on the outside of the building. And I have some examples. In the last few years we had a European EU project called EU-Pig, where we collected all kinds of solutions for heat stress. So you can find the website, and there is some information about the different solutions and the winner. Every year we had a winner for a specific topic, the challenge we called it. And this is how it looks like if you have a heat exchanger with water cooling for the incoming air. I think this is a dry situation, so that's also possible. But yeah, that's the principle, cooling. This is the fogging system. So this is the outside of the building. This is where the air comes in. So here you have some evaporation, and we reach 5 to 10 degrees lowering of the temperature of the incoming air. So that's really a lot. But still, I think the tail is the best sensor. So if we just measure the tail at the end of the process at slaughter, I think we know most of the information. Thank you.
Thank you.